So in this video we're going to work on evaluating expressions with rational exponents. And we've already looked at rational exponents a little bit. We know that our rational numbers are our whole numbers, positive and negative, and fractions. So we've looked at things like 9 squared. Our 9 is being raised to a rational exponent. And we know 9 squared is 9 times 9, or 81. And we've also looked now at negative exponents, if I wanted to know what 9 to the negative 2 was. And we learned that negative exponents need to be moved over the fraction bar. So our final answer here is 1 over 81. But what about our other rational numbers, our fractions? And this video is going to really focus on what are these fractional exponents telling us to do. So let's look at our general fractional exponent form. So I have a base and I have a fractional exponent, a to the m over n. And the way that we can rewrite this to make it look like something we already know how to evaluate is the numerator, the top of the fraction, is the power, and the denominator is the root. And when I'm saying root, I'm talking about things like square roots. So if I wanted to rewrite a to the m over n, I would write it as the nth root of a raised to the m power. And we're going to talk about what that nth root means, but let's look at it with an example that we already know how to do. So if we go back to that 9 to the 1/2, Miss Solomon's here as our student again. Looking at our general rule, how do you think you would simplify this?
I would make the 2 the root and make the 1 the power and put the 9 right inside of the box.
Perfect. Now, usually we actually don't write this little 2. I wrote it because I think simplifying these types of problems, it's easier to see. But the 2 root is the same thing. We usually just call that the square root. So what is the square root of 9?
3.
And why is it 3?
Because 3 to the second power is 9.
The square root of 9 equals 3, and the reason is because 3 times 3 equals 9. And I know that might seem simple right now because we worked with square roots a lot, but it's going to help us more when we go back and look at this nth root thing. So inside the parentheses, the square root of 9, we get 3, and we still need to raise it to the 1 power. And 3 to the 1 is just 3. So 9 to the 1/2 equals 3. So when we look at problems like this, 8 to the 2/3, I know for me looking at that, I don't necessarily just know the answer off the top of my head. It really is easier if we rewrite first. So the first thing that we're going to do is rewrite this problem. And when I say rewrite, we're going to apply that rule that we learned in the last slide. We have parts that are powers, parts that are roots. Miss Solomon, do you remember what we wrote is the power and what is the root?
Yes, the numerator, or the 2, is the power, and the denominator, the 3, is the root.
Perfect. So if I wanted to rewrite that, we put 8 inside of the radical. We're not going to call it a square root anymore because now what kind of root do we have?
A cube root.
A cubed root, a 3. So we can't use that symbol. We can't call it a square root anymore. We're going to call it a radical, and it's actually a cubed root. And then, like you said, the 2 is the power. So then our second step will be to evaluate the root. Because when we're taking roots of things, we're getting smaller numbers, and it's easier to do that first than to do the power. So to evaluate the root, we need to know, well, what is the cubed root of 8? So now we got to figure out, well, how do we do roots that aren't square roots? So if we think back to when I asked Miss Solomon what the square root of 9 was, she told us it was 3 because 3 times 3 gave us 9. So Miss Solomon, do you have any ideas on what maybe the cubed root of 8 would be?
Yes, well, following that same reasoning, if it's the cube root, now I need 3 things that multiply to give me 8.
And a lot of times this might be tricky for students trying to think about what multiplies by itself 3 times to give you 8. But you can just start guessing and checking some numbers. If I put a 1, a 1, and a 1 in here, I know that's not going to give me 8. So let's try a different number. And I'm just going to go to the next number, 2, 2, 2. Does that give me 8?
Yes, that works. 2 times 2 is 4. 4 times 2 is 8.
So this isn't my answer. This is just the thought process. So we now know that the cubed root of 8 equals 2. 2 is actually the final answer, not 2 times 2 times 2. 2 is just our final answer. It's the thing multiplied by itself that gives us 8. So if we come back up here, now that we know the cubed root of 8 is 2, I can replace it. And the last thing that we have to do is apply that power. And 2 squared?
4.
We get 4. So 8 to the 2/3 is actually equal to 4. So in the last slide, we talked about this thing that we kept calling the nth root. And the reason why we called it the nth root is because there's so many roots, we give it a variable name. So we already know the square root. And we usually don't write this little 2, but for right now I'm going to write it. So the square root, we know sometimes we just write the radical symbol. And it's something times itself 2 times. And like Miss Solomon told us in the last video, the cubed root told us to do something times itself 3 times, gave us the number underneath the radical sign. So what do you think the fourth root's going to be?
I'm going to say 4 times.
4 times. And so on and so forth. So the nth root just represents the general form of a radical, and the n tells you the number of times you're looking for a number to be multiplied by itself. So on and so forth. So let's look at an example closer. So let's say part of a problem asked us to figure out the fourth root of 81. So like Miss Solomon told us, it's something times itself, not a bunch of different numbers. It's all the same number. Something times itself 4 times is giving us our 81. And you can let the calculator help you test out some numbers like we did last time. If I put in 1, 1, 1, 1, we know that's not going to give us 81. If I put in 2, 2, 2, 2, well, 2 times 2 gives me 4, 2 times 2 gives me 4. That gives me 16, so that doesn't work. Well, what if we try 3s? Miss Alma, will you plug that in the calculator and double check it?
Sure. 3 times 3 times 3 times 3, and that gives me 81.
So would I say that the fourth root of 81 equals 3 times 3 times 3 times 3?
No, the fourth root of 81 equals 3.
Good. This, remember, is just our thought process to help us find the answer. Like Miss Solomon said, the answer itself is just 3. So let's try one more together. Let's say we wanted to simplify. We want to evaluate. So I'm trying to come up with a final answer for 16 to the 3/4. Thinking about our rules that we've went over, what would be your first step, Miss Solomon?
I would say to put it back into the radical form, and the root is 4, and the power is 3.
Good.
So now I have to evaluate the fourth root of 16, which means something multiplied by itself 4 times gives me 16.
Good, so we're going to start inside the parentheses. We're going to do that. Fourth root of 16. So something times itself 4 times gives us 16. And what is that something that gets multiplied by itself 4 times?
2.
Good, so now we figured out what goes on the inside. We know the inside, the fourth root of 16 is actually 2. And so now our last step is just to apply the power. And what is 2 cubed?
2 times 2 is 4, times 2 is 8.
Perfect.
Can I check that answer on the calculator?
Yeah, so if you want to check any of these problems, you can actually type in 16 to the 3 divided by 4 to see if you get the correct answer.
Oh, okay, I just did that, and 16 to the 3/4 power gave me 8.
Perfect. Now for these problems in class, you'll always have your calculator and you can always check them on the calculator. And if you want help on figuring out, well, how would I put something like this in the calculator, you can call over a teacher or a tutor and they can show you how to put it into a TI-83 or an 84. But for something like MCAS, this type of question is going to be in a non-calculator section. So you're really going to need to know how to do this without a calculator. But while we're in class, if you want to check it in the calculator, you can. And you can pause this right now and call someone over, and they can help you learn how to put it into the calculator. But let me show you an example of a question that was on a previous MCAS. So the more that you get comfortable with these types of problems, the more you're going to be able to switch between roots and exponents. So if we look at this MCAS problem, we know we can't use our calculator, so I'm not going to be able to just plug this in. And when you're taking the MCAS, you're going to be doing it by yourself. So really the goal of MCAS is figure out a way that you can evaluate this problem. But we're going to show you one way you could do it using the rules that we just went over. So the first thing that I see is that we have a root and we have a power. And I know that before I was switching it to make it look like that. So what if I took this, let me actually write it over. Let's say this is what I just changed it to. Thinking about our rules that we just learned, how could I go backwards to figure out what the problem looked like before I changed it to that form?
Well, we always said that the power was the numerator and the root was the denominator. So our numerator will be 4, and our denominator will actually be 2. Even though it doesn't say a 2, we know the square root is an invisible 2.
Perfect. Now, is there any more simplifying that we can do here?
Oh yeah, 4 divided by 2 equals 2.
And then do we know 5 squared?
Yep, 25.
So for this learning target, you really need to be able to go both directions with these problems. So in this problem, we went from a root to exponent form. But you should be able to also go from exponent form to root. So these types of problems, there's lots of different approaches that you can use. When we looked at something like 8 to the 2/3, we decided to say that that was the cubed root of 8 squared. But you might also see it written as the cubed root of 8 with the 2 on the inside and squaring. And you actually do end up with the same result. It's just a matter of, do you want to work with smaller numbers or bigger numbers? So this one up here, we said the cubed root of 8 was 2, and then 2 squared gave us 4. And if we take this route, the first thing that I need to do to the 8 is square it. So I end up looking at the cubed root of 64. And the only reason this way might be preferable is because it's easier for me to think of something times itself 3 times gives me 8, rather than something times itself 3 times gives me 64. It's just a matter of which math would I rather be doing in my head. And we find out that 4 times 4 times 4 gives me 64. So the cubed root of 64 is 4. And you can see we are still ending up with the same result. It was just a matter of which math do I want to do. Do I want to figure out what times itself gives me 64, or do I want to figure out what times itself gives me 8? So just to clarify, when we're looking at these two statements, they represent the exact same thing. So if on the MCAS it's written one of those ways, You don't have to keep it that way. You can change it to do the math that you want to do. If that 2's on the inside and you don't want to figure out what the cubed root of 64 is, move it to the outside. Or vice versa. It's up to you.